So after reading the paper, we find something in the title and abstract about author's interest in study is to determine the association between the average temperature and humidity with COVID-19 in Bangladesh. In my opinion, I think the authors want to find a general model for predicting COVID-19 pandemic cases based on average temperature and humidity in Bangladesh. Even we do not have enough evidence for the key points to reduce the COVID-19 cases are temperature and humidity in Bangladesh. From the information, we can know that even Bangladesh has much population with less regular testing. Due to the high temperature, and most cases were found in the Bangladesh is concentrated in cooler and drier region, and the test will influence the cases number. Now, we can understand why author choose the temperature and humidity and testing number as an independent variable. For this study, the author want to use the method in one branches of statistical inference, which is prediction. The statistical method we use in the study is called multiple linear regression. Since we have two numerical variables, temperature and humidity, to predict the COVID-19 cases number, the study includes the 9,455 confirmed cases during the observation period from March 8, 2020 to May 3, 2020. They are our statistical sample data. First, we could find the assumption model for the study. We use multiple linear regression to predict y equal to beta 1 times xi1 plus beta 2 times xi2 plus beta 3 times xi3 plus epsilon. For I, it means the date number from 1 to 56. Y is number of daily confirmed COVID-19 cases, and X1, X2, and X3 are average daily temperature, humidity, and reported number of testing on a daily basis. Epsilon means the random error. Then we can use a histogram to show the approximately relationship between the temperature and number of the COVID-19 cases. Between the humidity and the number of the COVID-19 cases, each graph shows that with the increasing of the temperature and humidity, it will increase the number of the cases. We can guess that the humidity and temperature have the negative association with the number of cases. Then, we use the sample data to get the multiple linear regression model for this example. Since the reported number of testing is changing, we adjust the model, and we only get temperature and humidity in our linear regression as variable. From the table 2, the coefficient number of temperature average is negative 11.76, and humidity is negative 8.79. We have more confidence to say the humidity and temperature have a negative association with the number of cases. And this linear model, if the slope parameter is 0, then it means that knowing the value of x does not help us predict the value of y. Since the p-value of the temperature is 0.038, which means that we have moderate evidence to against this new hypothesis, which knowing the average temperature does not help us predict the number of cases, and the p-value of the humidity is 0.005. We have strong evidence against the new hypothesis, which is knowing the humidity does not help us predict the number of cases. From the coefficient number, we can know that for every unit increases in average temperature and humidity, negative 11.76 and the negative 8.79 unit decrease in daily confirmed cases in predicted. Holding all other variable constant, we might get the conclusion is high temperature and relative humidity reduce the transmission of COVID-19, but there exist some limits, like we do not have enough evidence to show that this linear model has high accuracy, like also some unknowns, including how the virus is mutating and evolving, case fertility ratio, reproductive number, and direct versus indirect transmission, population mobility, and population endurance. We should study them and maybe add them to our linear regression model in the future study. And also, due to the disease surveillance system is still improving, under reporting may still occur and could lead us the lack of some important sample data and affect our main findings, especially at the beginning of the COVID-19 outbreak.